Alright,
No,
today we're going to learn how we can represent
No, that would be it.
I've seen quick.
Like what's Ricky Bobby?
complex numbers in a form called polar form. Last lesson where we were learning about the magnitude of a number and the direction of a complex number, we're going to put it together and write it in something called polar form. Now consider if we have this form over here, complex number z is equal to a plus ib. If we want to write this in polar form, what we can say is the magnitude of z, cis, and then we're going to write the argument of z. This over here is called polar form. Now, conditions that we need to consider here is that, firstly, one, the magnitude of z is always going to be greater than or equal to 0. Just has to be. Why? Because if it's less than 0, then you're not going to have the magnitude, are you? Secondly, the argument. The argument of z is always going to be between the values of negative pi, oops, that's an ugly symbol, and positive pi. If they're outside of that domain, then you're not in polar form. You're in a non-standard form. It's just not polar. Does that make sense so far? So as opposed to representing a number by its real and imaginary components, we're simply going to represent numbers or complex numbers in terms of its length followed by its direction. This guy over here, we pronounce it as cis. Basically, it's a shorthand version of cos arg z. Why cos? Just cos.
Funny.
Yeah, my year 9s thought that was funnier than you guys did.
That's disrespectful.
I sine arg z. The reason for that is going to be revealed next year. For now, we can just accept this as objective truth because we're not going to do anything by expanding these yet. Seem okay? All right, now, example 1, what we want to do is we want to represent the following number in its polar form. Give me your favorite number. Don't even think about it. The first number that pops into your head, please, Emma. 7. Z equals 7. Take. Levi, you've been yak,
13,
yak.
sir.
So, what number?
13, sir.
If you hadn't been yakking, you would have known that I wanted you to pick the number 11.
I knew that. Yeah, my bad.
We're going to represent a complex number z in its polar form. Right now it's in Cartesian form. So what we first need to do is we need to find the modulus of this number. Does anyone remember how do we find the modulus of z? The modulus of z is just the square root of the sum of the squares of these.
Of the sum of this. Oh, yeah.
Let me write that in.
That's what the modulus is.
Or another way to think of it is, it's just Pythagoras' theorem.
Equals pi.
So we need to calculate what this is. Do we all have calculators?
106. No, 7.
What does that say?
7, yeah. 100.
What does that
No,
say?
you're pretty good.
107.
That bottom line
49
over there
plus-
after Z.
I got this, Harry.
After z, that's closing parenthesis,
No, don't.
is less than or equal to pi.
Anything. Here's mine. May not.
That is not
Should
true.
still.
Oh, so it's good.
That's no example wrong.
Someone said that.
No, I did.
Oh, okay. Happens to the best of us.
I spelled it wrong.
Okay, so the length of Z is root 170 units. That's our length of the number. Next part is we need to know what direction it's pointing in. What do we do? What do we scribble on our page to help us understand what calculations ensue?
Cartesian plane.
It's not Cartesian plane.
The argument diagram thing, image.
Diagram.
The argument of Z is going to be something. We don't know what it is yet. So we do a little scribble and we think, which domain are we pointing off in the direction of? We're in positive, real, negative, imaginary, so
Second quarter. Oh.
we're going down like that. Now the angle itself isn't important. It's simply the domain we're after. Because drawing this diagram alerts us to the fact that we're looking for this angle in here. This is going to be our theta is negative phi. So if we put this together, we simply know it's going to be negative tan, the inverse tan of the would-be positive versions of these guys, 11/7. Next, we just put this in our calculator. Yes, Emma?
How do you know it's in the fourth quadrant?
The fourth
Because
quadrant?
That is lovely.
7 is positive
Yeah.
to the right, and then negative is down. So it's down, right down. To the fourth
Positive
quadrant.
down.
Yeah.
Like that.
7 is a real
Positive,
number.
real,
11 is
negative,
Is
imaginary.
the x-axis.
Maybe it's
And
So
then-
you did x
So
axis
7's a real
first.
number. So
And
the
if
real
it's
numbers are
positive,
the
then
x-axis,
negative, you go that way.
and the imaginary numbers are the y-axis.
Okay, that makes sense.
Yeah, you guys are shitty teachers.
We spent an entire lesson on that.
Who? Yeah.
Camera's on.
No. No, I was telling her, so she didn't know.
Okay.
No, not her.
So, we put in the inverse tan of the would-be.
But your maths is good.
And therefore, we get a negative angle.
Yeah.
Is this okay so far? If you were away in the last lesson, you would have missed out on the argument and stuff. If that's the case, don't stress. We'll spend some time working on it.
Negative.
What's her thing?
So it's negative. What is it?
Oh, I don't know.
Jesus Christ.
One.
Just one.
Point.
00406.
Forgot your name for a moment, Harrison.
Significant figures.
Oh yeah, not
It doesn't include
Okay,
results.
so our argument of Z is going to be negative 1. So therefore, if we want to write this in polar form, then Z is going to equal the root of 170 cis negative 1.00. We can use this expansion over here to put it back into Cartesian form, but we're not too interested in that today.
No, she'll be there.
Are there any questions so far?
Z equals A plus IB. Oh no, sorry. So,
No, I was telling him what
Which-
formula we're using.
yeah.
Seem okay?
No, see how there's this.
So is that the answer?
oh, the Z
Yeah.
is R.
Okay, now the next question is, we can do these calculations simply by using our knowledge from the last lessons and just putting it in this form. But what if we want to go directly in this form from our calculator? Well, funny you should ask that, even though you didn't really ask that. Are you ready to level up?
Ready?
Okay, suppose you want to go directly into this form. You can simply make sure your calculator's in complex mode, so shift menu. We want to have a rad time and we want to have a complex time. So make sure you're in rad and complex.
Use my calculator.
Next, what we're going to do is we type in the value. It's 7 take 11 shift I. Next, let's
Alpha I.
store it inside of A. We don't want alpha I, that's something different.
Where's there it is.
Yeah, find the arrow.
The arrow's over there.
Where's the
Yep.
Okay,
Click.
next, we want options, F3 for complex, and then we're going to go across. Here's polar form, alpha A, F3, and it automatically puts you in polar form. Notice that it's not using cis, it's using the sort of like a triangle. That's a phasor symbol.
Looks like
You only get to use that if you go to university and study this. Sitting up.
Silly
We don't use that symbol in SACE because it's not a part of SACE.
I don't know.
Uh,
How'd you get that?
Options complex and then it's there. But
Come
yeah.
on, Bill.
Is that the answer, sir?
Yes.
Craig? Sorry.
No, the calculator's lying to us.
Oh, right, heard.
I don't know what that is.
Oh,
You're okay with that?
That's the answer.
No, that is correct, Amanda.
You sure?
I assume it is.
She's not lying.
John, there's sort of a camera there.
Is it?
What up? Sorry.
Is that a problem, Harry? Do you want to
Well,
just be quiet, Harry?
Yeah, Harry's the keep to himself.
Wait, I have to tell you that
Well,
ages got on.
the annual viewers.
No. Alpha. Alpha.
Is it us?
And then
the huge button.
there is no huge button with it.
That one.
Zoe? Guys, did we get it?
Yeah.
Emma?
Okay, and then you go.
I found the huge button.
And then option. G.
No, so I don't know where
Is he kidding me though? Just gets better with him.
Without using your calculators.
I don't know how to do that.
There you go.
Can you put omega in complex mode? Sorry, not complex, in radians for me, please. Without using the automatic feature on your calculator.
What does that mean? Wait, what?
Can you express omega?
Omega? What's omega?
Omega's W.
The W.
I know.
Can you put this one into polar form for me?
We'll try, sir. We'll try.
Try.
You better
Sorry, do or do not. There is
Oh,
no
wait,
try.
that's the Yoda quote. Oh,
What's the
I know
difference
that one,
between
sir.
omega
You don't know
and
what.
Z?
Sorry.
Do not.
No, I have like a lolly dispenser and you
Wow, camera's on.
Alright, so you can use your calculators to to calculate inside the square root symbol here and simplify, and you can use your calculators to evaluate the inverse tangent. But I want you to do the steps manually, because not every question is going to permit you to do it simply in a calculator. Some things need to be done manually. There's surplus of chairs in here.
You can use a calculator. That's the
You're about to get on a seating plan. That would be very embarrassing for a year 11. Need a diagram of some sort. Are we there? Tan away, and you're not sure about the argument, that's fine. We'll work on it if they discuss it.
Oh, you sorry.
And once you've done your calculation, your calculator should agree with you that you've done it properly. Is anyone having calories to be by?
No, sir.
A little bit less. Ladies? Boys? Good? Alright, awesome. Now, the next question is, why bother? Yes, Maya.
Is it to the angle? Which angle is it?
Which angle? It can be one of four. The angle itself is always going to be measured. We'll do it in orange.
Is it from the?
Angle theta, which is our argument, is always starting from the positive side of the real axis and swinging toward the line that's pointing out, or our complex number. So in this case, it's always like that. Whereas in this case, see how it's shorter to go from the real part, so the positive part of the real downward? We go in that direction. And because of that, our argument's always between negative pi and positive pi. Now, how we actually work out what this orange angle is will change based on the four quadrants that we're in, but we'll come back to that after this. Okay for now? All right. Now, the question is, why bother? Why would we go through the effort of changing our complex number into this form? Any ideas? I'll give you a hint, it's on the board.
What did you say?
Why would we bother writing our complex numbers in polar form when we have to do all of this to get there?
Representing
Represent a
direction.
complex number with like.
Can? Boys?
Representing direction.
Representing direction? Mm.
Oh, that's
Multiplication.
I was reading the stuff behind his head.
It makes multiplication and division
I was reading that stuff.
really straightforward. We'll see.
You saw the diagram.
I was reading that.
Is the camera in the way, guys? Okay. Okay. The reason why we do it is it makes multiplication and division really simple. The way in which this works is we're going to say that we have omega z. If we want to evaluate this guy over here, this might be turned into modulus of omega cis argument of omega times modulus of z cis argument of z. And now, look what happens. Omega z. We simply multiply the coefficients out front of cis. Then, it's the argument of omega plus the argument of z. So rather than having to do binomial expansion, or binomial expansion collecting like terms, when you multiply two complex numbers in polar form together, it's a matter of causing a dilation or another way to think of it is it's a singular multiplication and an addition, which I like to refer as a rotation.
All you do is put it in a calculator.
You can, but it's not always going to be in numerical form.
That's what we're learning though.
We're doing numerical form because if you do algebraic, it's going to get too complicated and then you guys get sad. So we start off in numerical, so that way you can practice numerical.
Is this our last lesson before
Yeah.
we get ready for the test?
This is our last learning intention. The last bit of information. Crikey indeed. Okay, similarly, when we do division, you divide the lengths, and then
Next Friday. I have 2 3s.
you subtract the arguments from one another. How cool is that?
So
Very
Reasonably cool.
Reasonably cool.
not reasonably, Dylan. It is very cool.
Oh, sorry, man.
Oh, I don't know what that is.
Do we cheat sheet for this test?
Hope.
Do we get a cheat sheet for the test?
Okay, we want to simplify this guy over here. Omega z. Would we go back to our Cartesian form and multiply it out? Or is there a simpler way to do this?
there's a simple line.
There's a simpler way to do it. Simply get the polar forms. It's going to be root 170 cis negative 1.00. Multiply it by omega, which is 5 cis 2.5. Apply the formula. It's 5 root 170 cis negative 1.00 plus 2.5.
So you see like this W with 2 lines?
Which one?
The only W with the 2 lines.
Yeah.
On that bit.
Yeah.
That's equal to like that root thing from the top, or the bottom.
5.
Yeah, 5.
That-
And then
Yeah, sorry, I knew
with
that.
it. Well, you said you didn't understand, so it's not really going to explain it.
So what we're learning today, guys, is firstly we're learning the conversion. Again, every single calculation you could do today can simply go into the calculator, but we're not going to do that because we need to know the method. We need to know the understanding as to why we do it. You can verify your answer in the calculator or the solutions, it's up to you. After that, we're getting some practice in on how to apply the rules of multiplication, the rules of division. This is quite an important thing because actually for most of you it's not that important, but for some of you it is quite important because using this knowledge here allows you to find all the answers to square roots, cube roots, fifth roots, 7 roots, 7th roots. So if you do a square root of a number, how many answers do you expect?
Not that many. Wow.
2.
2.
2, yeah.
If you take a cube root, how many answers do you expect?
3.
3. It allows you to find every single root.
Actually, yeah.
Seem okay? That's not this year's learning, that's next year's learning, if you want to learn about it. Seem okay?
Yeah.
Yeah.
All right.
You didn't make this